Hey guys, today we're going to be taking a look at a process called completing the square. And I've broken this lesson apart into two videos for a couple reasons. The first reason, of course, is that it would be really long to do this in one video. And secondly, I want you to just spend your time on this first video really focusing on what completing the square means in terms of a visual representation. Okay, so for this first video, you won't be taking a whole lot of notes. We're going to write a key question here in a minute. But other than that, your focus needs to be on the visual representation so that you can carry that over in your mind as we go forward with the algebraic video next. So we've been working on solving quadratics by factoring and solving, by getting x squared alone and taking a square root. These are two very good methods to find those two solutions. However, sometimes when we go to solve, neither of those will work. This looks like a factoring problem, but when I go to take a times c, 1 times 1 is 1, nothing multiplies to make 1 and adds to make 4. So I can't do the grouping, I can't put them in the 4 boxes. I'm kind of stuck, yet I know that they have two solutions, so how do I go about solving this? Well, that's where the process of completing the square comes in. So please write this part down in your notes, and then I'm going to exit out here and go to the visual graphic of what's going to happen when we talk about completing this square. So please write this key question down, and then you sit back and sort of relax and watch what's happening visually so that you can carry that picture over. Okay, I'm opening up here a picture of some puzzle pieces. So geometrically, we're going to be talking about what it means to complete a square. And I want you to think about this literally. A square, same side length, width, 90-degree corners, all of that. So think about a square, and then we're going to basically build a square using some algebra tiles. Algebra tiles are just puzzle pieces that represent parts of algebraic expressions. So like, for example, this big tile, this big piece, is going to represent an x squared, and this piece right here is going to represent an x. And knowing that and using that, we can represent or build algebraic expressions that represent some of the things we're going to be working with. So for example here, I have x squared plus 4x and then plus sign and then a blank. The key question we're going to look at is what would I need to add in order to complete a picture of a square? That means using these puzzle pieces, I need to create a picture of a square. So not all separate, but putting them side by side, I need to be able to make a square. Well, if I stack them all this way, you can see what's happening. I'm not making a square, I'm making a giant rectangle here. I need to focus on maintaining the same length and width to create my visual picture of a square. Knowing that I'm going to need to grab some extra stuff over here because the key question says, what do I need to add in order to complete the picture of a square? So I think I'm going to grab this X tile here and maybe turn them this way. And if I put two X's down the side here, just like I put two X's this way, I'm maintaining the same length and width, kind of creating the outline of what could be a square if I completed or filled in this part of my picture. So the question is, what would I need to add to my picture in order to complete the square? Well, I'd need to grab some of these little tiny pieces, these little ones, and place them over here until I complete my square. How many of them will it take? 2, 4, 4 little pieces. Okay, 4 little pieces to complete the square. And now I have a perfect picture of a square. So let's look at another problem. What if you had x squared plus 6x plus something? What would need to go in that blank in order to complete the picture of the square? How many of those little ones tiles would fit down here? Well, let's see. If I place them all over there, you can kind of see what's going to happen. I'd have 3 rows of 3 here. So that means that 9 little ones would need to be placed over here to complete the square. Notice how I had x squared plus 6 x's, and I arranged it in a way so 3 little x's went lengthwise, 3 little x's went widthwise, creating a space of 9 down here that needed to be filled in. Let's continue on with another picture. What if you had 8 x's? How would we stack those little x's? Well, we'd place 4 this way and 4 this way. Well, what kind of space then would need to be filled in down below? If I draw in what would happen, since I've stacked the x's 4 by 4, I've created a space where 16 little tiles would need to be filled in. 16 would be what I need to complete my square. Okay, let's take a look at some without the pictures. Visualize in your head how you would place those x's around that x squared. So if I had 10 x's, I would place it 5 by 5. And I'd have a 5 by 5 little space that needs to be filled in. So I'd need to add 25. What if I had negative 18 x's? Well, even if it's negative, it doesn't really matter. I'd go negative 9 by negative 9. Negative 9 times negative 9 is positive 81. What about negative 14? That'd be negative 7 and negative 7, so multiply those, you'd get 49. What about 12? Half of 12, 6 by 6, so I'd have a space of 36 that needs to be filled in. If you're starting to see how these blanks get filled in, that's the important part, because we're going to use this step in our process called completing the square, and we need to know how to fill in that blank to make this happen. Okay, so now that you have the picture in your head, let's go ahead and I'm going to end this video now, and you're going to need to open up the next one. We're going to do a few examples of the whole process of completing the square.